Welcome to this expert-level training module on Microsoft Foundry. Today, we are diving deep into the implementation of generative AI by creating a lightweight chat client application using the Foundry SDK. Welcome to this expert-level training module on Microsoft Foundry. Today, we are diving deep into the implementation of generative AI by creating a lightweight chat client application using the Foundry SDK. To successfully integrate artificial intelligence into your enterprise workflows, you must move beyond the Foundry portal's web-based playground and write custom software. A client application is a program that you write specifically to connect to a service or an AI model to utilize its advanced capabilities. Your custom code is responsible for automatically sending user requests to the service and securely receiving the generated results back. This automation makes it possible to process massive volumes of text or seamlessly integrate AI analysis directly into your existing business workflows. To establish this connection, your application uses an application programming interface, universally known as an API. An API provides a strict set of rules that perfectly defines exactly how two separate pieces of software should communicate over a network. However, writing raw HTTP requests can be cumbersome and error-prone. This is where a software development kit, or SDK, becomes invaluable. An SDK acts as a client library. It is a collection of ready-made, highly optimized code that developers can import into their applications to easily talk to a service or API without manually managing complex network protocols. By utilizing the official OpenAI Python library, which is a powerful SDK, developers can build robust Python applications that interact with deployed models entirely through native Python code rather than raw HTTP web requests. Throughout this module, we will explore exactly how to set up your development environment, authenticate your connection, and write the specific application logic required to build a functional, real-time chat client. Mastering these SDK concepts is absolutely essential for any developer looking to build scalable, intelligent software architectures. Let us begin our deep dive into client-server interaction. While there is no specific code for the high-level concept of an SDK, integrating an SDK fundamentally transforms your application code. Instead of writing dozens of lines of Python to manage HTTPS connection pools and JSON serialization, you import a single library that securely handles the complex network transport layer on your behalf. Take a look at the flowchart on your screen. It visualizes the connection pathway. Before we write a single line of Python code, we must rigorously define the architectural pattern we are building. An AI client application utilizes an advanced model, data, and precise application logic to process and return results. The application logic is the specific code or workflow that sends requests to the model, receives the response, and transforms those results into a readable format. This entire end-to-end process is known as a client-server interaction. Understanding the distinct separation of responsibilities between the client and the server is a fundamental concept in software engineering. In our architecture, the client is your lightweight chat application. The client has several strict responsibilities. It must present a user interface or a command line interface, securely collect the user's input, which could be text, voice, or even images, and precisely format that input into a structured prompt payload. Finally, it must send the API request over the network and beautifully display the returned output to the human user. On the other side of the network connection sits the server, which in the Microsoft Foundry ecosystem is your specific model deployment. The server's responsibilities are heavily computational. It must securely receive the formatted prompt, run the complex neural network inference on the deployed model, dynamically apply your defined system instructions, and enforce all mandatory responsible AI safety guardrails and content filters. Once the inference is complete, the server returns the generated output, whether that is text, an image, or structured JSON data back across the network to the client. By strictly dividing these responsibilities, we ensure that the incredibly heavy computational lifting remains securely hosted on Azure's massive infrastructure, while your client application remains exceptionally lightweight, fast, and responsive, capable of running efficiently on a standard laptop, a mobile device, or a simple web browser. The client-server boundary dictates how you design your local codebase. Your Python script does not require massive local CPU or GPU resources, nor does it contain the machine learning weights. It is strictly designed to act as an asynchronous HTTP router, pushing data to Azure and awaiting the computational response. This diagram strictly defines the division of labor. The client application handles presenting the UI, formatting the prompt, and transmitting the request. To begin building our lightweight chat client, we must establish a secure local development environment and gather our vital configuration prerequisites. First, you must have a Microsoft Foundry resource provisioned within your Azure subscription, and you must have successfully deployed a generative AI model such as GPT 4.1 within a Foundry project. During the deployment phase, you assigned a specific name to this model, known as the model deployment name. It is absolutely critical to remember this exact name, as your code will use it to route requests. For instance, if you named your deployment GPT demo model, that exact string must be passed in your API calls. Next, you must retrieve your Foundry resources, secure endpoint URI, and your cryptographic API key from the Foundry portal. Because these values represent highly sensitive administrative access to your cloud environment, you must never hardcode them directly into your Python script in plain text. Instead, best practices dictate creating a hidden configuration file, typically named .env. This .env file acts as a secure vault on your local machine to store your environment variables, such as your endpoint URL and your API key. Notice that your endpoint variable will explicitly contain the name of your specific Foundry resource, uniquely identifying your cloud architecture. To interact with this configuration, you will open your code editor's terminal-a built-in command line window and install 2 mandatory Python packages using the pip package manager. You will install the OpenAI library, which is the official SDK, and the python.env package, which provides the critical functionality required to seamlessly load the secure variables from your .env file into your application's active memory at runtime. Preparing this secure, robust configuration foundation guarantees that your application will authenticate flawlessly with the Azure cloud, while strictly adhering to enterprise security and credential management standards. This code represents the contents of your hidden .env file. These strict key-value pairs sit securely on your local hard drive. By keeping these sensitive values entirely segregated from your main Python execution script, you actively prevent devastating security breaches that occur when developers accidentally upload cryptographic secrets to public GitHub repositories. Observe the credential workflow. With our environment securely configured, the next architectural step in our application code is to initialize an authenticated client object. In object-oriented programming with Python, a class acts as a foundational blueprint that defines a specific type of entity, dictating exactly what data it holds and what dynamic actions it can perform. When you write code to interact with Microsoft Foundry, you utilize the OpenAI class defined within the SDK. This class serves as the strict architectural blueprint for connecting to the OpenAI API. When you create a specific instance from this blueprint, you are instantiating an object. Our goal is to create an authenticated client object. This is a highly specialized, service-specific object that possesses the capability to securely make authorized API calls to the cloud without requiring your application code to manually construct complex HTTP headers or manage raw cryptographic tokens for every single request. To build this object, your Python script must first utilize the load_.env function to read your hidden configuration file and inject those values into your application's environment. Following this, you use the standard OS package, specifically the os.getenv method, to pull your endpoint URI and your API key directly into active memory. It is imperative that the variable string names you request in your Python code match the exact spelling defined in your .env file. A simple typo here will result in missing values at runtime and an immediate authentication failure. You then pass these retrieved credentials into the client initializer. Once successfully instantiated, this authenticated client object becomes the absolute core of your lightweight chat application. It manages the persistent connection to the Azure cloud, handles network retries behind the scenes, and provides the streamlined Python methods you will call to submit your natural language prompts and retrieve the highly advanced generative AI completions. This Python snippet demonstrates the secure initialization process. First, load_.env actively maps your hidden file into system memory. Next, the Azure OpenAI client constructor is invoked, pulling the endpoint and key directly from memory via os.getenv. This safely produces the client object without ever exposing plain text secrets in the script. This visual walks through the exact initialization sequence. Now that our authenticated client object is fully initialized, we must format our data and invoke the generative AI model. In modern Foundry development, this is accomplished using the Responses API. The Responses API is the modern, unified programming interface within Azure OpenAI designed specifically for interacting with advanced language models. Unlike legacy endpoints, the Responses API is architected to handle complete, rich AI interactions, including complex conversational chat and multimodal inputs, rather than just simple text generation. It is exceptionally useful when you require highly flexible conversational style analysis that dynamically adapts to user input. To use this API effectively, your application code must structure the data payload meticulously before sending it to the server. You do not simply send a single string of text. Instead, you construct a structured JSON array of message dictionaries. Each message dictionary within this array must contain 2 critical key-value pairs: a role and content. You typically begin the array by defining a message with the role of system. The content of this system message contains your strict behavioral instructions, such as, "You are a highly helpful technical support agent." Following the system message, you append a message with the role of user. The content here represents the actual dynamic question or prompt typed by the human interacting with your lightweight client application. Once this structured message array is perfectly formatted, your code invokes the client object's specific creation method passing both the targeted model deployment name and the message array as arguments. The SDK instantly serializes this data, transmits it securely over the internet to your dedicated Azure endpoint, and patiently awaits the server's computational response. Understanding this precise data formatting is absolutely critical for orchestrating reliable, context-aware AI conversations. Here, we dynamically construct the messages_payload list, containing our designated system and user dictionaries. This structured list is then passed directly into the client.chat.completions.create method, alongside the specific deployment model string, securely triggering the massive computational inference process in the Azure cloud. Here we map the prompt engineering data flow. Client application data is used to construct a messages array. Once the generative AI model running on the Azure backend has successfully completed its inference phase, it transmits a comprehensive response back to your lightweight chat client. It is crucial to understand that the SDK does not simply return a raw string of generated text. Instead, the responses API delivers a highly detailed, deeply nested JSON response object that contains a wealth of operational metadata alongside the actual language completion. This metadata includes critical information such as the unique request identifier, the exact timestamp of the transaction, and highly detailed token usage statistics that inform you exactly how much computational budget was consumed by the prompt and the subsequent generation. As an AI developer, your application logic must elegantly parse this complex response object to isolate the specific information the user requested. Using Python's object attribute notation, your code drills down into the response payload, typically accessing the choices array, selecting the very first choice, and then extracting the specific content string from the nested message object. Once this raw generated text string is successfully isolated in memory, your client application's final architectural responsibility is to display it to the end user. In a simple terminal-based script, this involves executing a basic print statement. In a more sophisticated enterprise application, this string might be rendered into a dynamic web interface, injected into a mobile application view, or passed downstream into another automated business workflow. By successfully parsing the API response and cleanly presenting the data, you close the complete client-server conversational loop. Your lightweight application has seamlessly taken human input, securely leveraged the massive intelligence of a cloud-hosted foundation model, and delivered actionable, generative insights directly back to the user in a matter of milliseconds. This critical snippet parses the nested JSON properties returned by the SDK. It navigates into the choices array, grabs the first item, and extracts the target content string. It also captures the total_tokens metric from the usage object. Finally, it uses Python fstrings to dynamically print the results directly to the user's terminal console. This visual breaks down the response parsing logic. Upon receiving the complex JSON response, the code simultaneously extracts metadata and navigates the choices array. As we conclude our deep dive into building chat clients, we must highlight a critical architectural distinction within Microsoft Foundry: the difference between interacting with pure generative models versus interacting with AI agents. Throughout this module, we have focused on calling models directly via the OpenAI Responses API. When you use a model on its own, you are accessing raw intelligence. You are requesting pure inference, asking the system to take a prompt and immediately generate an output. However, agents are fundamentally different. An agent in Microsoft Foundry is a packaged, highly reusable AI component that brings together a model, strict system instructions, and external tools, such as web search or database access to perform complex, multi-step actions. Agents are task-oriented workers built on top of that raw intelligence. If your enterprise scenario requires an agent rather than just a conversational model, your client application will utilize the Foundry Project's SDK to connect to the workspace and invoke the agent using the specialized project API. The Foundry SDK brilliantly exposes both the project client for Foundry native operations and the OpenAI compatible client for standard chat completions, allowing developers incredible flexibility within a single codebase. By mastering these SDK interactions, you empower your organization to build everything from lightweight virtual assistants to highly autonomous digital workers. Thank you for joining this expert technical training module. Please be sure to like this video, subscribe to our channel, and share this knowledge with your engineering teams. To truly accelerate your career and master these advanced cloud concepts, I highly invite you to visit quicktechie.com. At QuickTechie, we offer premium certification prep materials, including extensive Q&A banks, comprehensive ebooks, audiobooks, advanced training modules, and expert interview guides. Build intelligently, deploy securely, and we will see you in the next lesson. To execute agentic workflows, the script imports the AI project client. Utilizing a secure connection string and Azure Entra ID credentials, the code securely reaches into your specific workspace. By calling project_client.agents.get, The application retrieves your highly configured digital worker, enabling tool execution far beyond simple text generation. Our final diagram illustrates the client routing decision.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.